Hey guys, so in this video we're going to be doing some tips and revision for probability, going over some of the important concepts we've learned as well as the common mistakes. However, we're not going to look at any new content or go through anything in depth, but rather an overview just to make sure you've got a broad understanding of probability. So we're going to talk about decimal places. Now, not all the tips and revision here are just specific for probability, but rather maths in general. However, they're still important either way. So decimal places, so just 3 decimal places. Question, it was 0.01345, then the 3 would be 0.013. So the common thing is to forget the 0, however the 0 still does count as a decimal place. So as you see, the total would be 3, and then 0.9999 to 3 decimal places. Well, that rounds, well, you look at this one here, 9, that rounds up. The 9 rounds up again, and the 9 rounds up, so it carries all the way to make this one a 1. Then instead of just leaving it as 1, you must also put the 0.000 as the last of 3 decimal places. So even if it's a whole number, even if it's only got 1 decimal place and the rest are zeros, you still have to put those 3 zeros in, so don't forget those. And then if it doesn't say a decimal place, you have to give it as an exact value. So an exact value, here are some examples, just 11 on 4. So basically not decimals. 11 on 4, root 6 on 2, 3, 2 root 3. So what about the square root of 24 on 4? Is that an exact value? So this is an exact value. However, it's not in its most simplified form. So you wouldn't want to write that as your final answer, as you must simplify it first. So if you look up here, we have square root of 24 on 4. Now I know that 24 can be made up of 6 times 4 on 4, which is equal to the square root of 6 times 2, because the square root of 4 is just 2. That's divided by 4, 2, and that equals the square root of 6 on 2. We can see that's even one of the examples. So that would be your final answer. So that is an exact value. However, with exact values, you want to make sure it's in the most simplified form. So another thing is that mutually exclusive does not equal independent events. So they're different things. So firstly, mutually exclusive. So mutually exclusive is when the probability of A intersection B is equal to 0. With a Venn diagram, you can graphically see that that's A, that's B, and there is no intersection at all. So A cannot happen whilst B is happening. An example is if you're enrolling in a subject and you can't do both at once, then there could be mutually exclusive events. However, independent is different. They can still occur at the same time. However, if you look at the formula, the probability of A intersection B is equal to the probability of A times the probability of B. So they can occur at the same time. However, they don't affect each other. You can sort of think about independent events. So if one occurs, then it doesn't affect anything to do with the other. If the other occurs, it doesn't affect anything. And that's the reason why they can still both occur, because if one occurs, it doesn't change if the other can occur or not. So conditional probability. So this is an important topic. And you really need to remember the formula. So the probability of A given that B is equal to probability of A intersection B on the probability of B. So a common thing to look out for in questions is as soon as they say given that, or you see that the straight line down in the probability, you know that it's conditional probability. So they can have a question without saying given that, and that's why you always need to understand conditional probability and what it actually means, and you can apply it. However, if you do see given that, then you know that straight away it's going to be a conditional probability question. So one of the things I mentioned before was what happens when A and B are independent events. Now I just want to mention what independent events are before. So have a think. So logically, if they're independent, they don't affect each other. So if I say what's the probability of A given that B's occurred, then it doesn't matter if B's occurred or not. So it should just be the probability of A. And we can see that in the formula. So the probability of A intersection B is the probability of B. Given that they're independent, we know that the probability of A intersection B is equal to the probability of A times the probability of B This is over the probability of B, and that just equals the probability of A. So there's these things called expectation and variance theories. Basically, they're just how variance and expectation, or the mean. So you can sort of expectation refers to EX, so the expected value, which can be thought as the same thing as the mean. And how constants as well as variables change these. So just put them down as you need to know them, but you don't need to really understand them too much. It's good if you can understand them, but don't worry if you can't, but make sure you actually know the formulas. So you can see them down here. You can think about like EAX equals AEX. So what's that basically saying is that if you have a mean, so you have the mean here, and you times every value by 2, then your distribution is going to look like something like that. And the new mean will be 2 times whatever the old mean is. So you can, the mean of the constant in the middle times x is going to equal the constant outside times the previous mean. Then the expected value of a constant is just equal to constant. That's because if you have, let's say, 6, then what's the expected value of 6? Well, it's always going to be 6. So the expected value of a constant will just be a constant. Then another important thing to note is this, which is e brackets x squared does not equal brackets ex close brackets squared. And that's really important when using the variance formula, because if you assume they are equal, then you always get the variance equal to 0. So some variance theorems. A common mistake is to leave out the squared. So you have v ax plus b equals a squared out on the outside times vx. And this a squared is because when you take the variance, you're looking at sort of like the mean, whatever the values are, minusing the mean squared. And so that's why you have a squared there with the constant, because when you're calculating variance, there is a squared term. Nothing is a variance of a constant is equal to 0. So that's different. So these are not equal. So the variance of a constant is equal to 0 because if you have a constant, let's say 7, then if variance refers to spread. So what's the spread of 7? Just 0. There's no spread when there's only one number or one constant.